All right, so let's take what we've learned about exponents and some of the rules and actually put it into practice. This is a little bit more fun than just learning about the rules because you're going to be actually doing some math. And it's kind of cool to see that some problems that look really, really crazy, you can actually do without a calculator. So let's review the properties very quickly and then we'll get started. Anytime you multiply two terms that have the same, or two variables that have the same base or two numbers, you can add the exponents. For example, x squared times x to the third is exactly the same as x to the fifth because you have x times x times x times x times x times x. Right? When you divide, same base, and you divide, you can subtract the exponents. And in this example here, we see that 6x to the sixth divided by x squared is the same thing as x to the fourth. All right, we learned about the power rule. If you raise an exponent to a power, you multiply the exponents. For example, x squared to the third is the same as x to the sixth. So 2 times 3 would be 6. We talked about the distributive rule. We won't need that yet, but I wanted you to keep that in your mind. So if you have like x times y, and both of those are in parentheses, that's the key. The cubed, x to the x times y cubed, the cubed goes with everything inside. That's the key. I don't think we'll see any of that in this exercise, but again, keep that in mind. Same with division. If you distribute the squared, it goes with both. So you're not only squaring the top, you're squaring the bottom. And we talked about negative exponents. Anything to a negative exponent, you invert, take the reciprocal, flip it over, whatever helps you remember that. Move it to the other side of the division bar. If it's on the bottom, it goes to the top. If it's on the top, or if it's not on one at all, it goes under 1. All right, so let's look at a couple of examples. And we're going to try to do these without a calculator. We're going to use the properties. All right, so we have a division problem here. So our rule of exponents for division says we can subtract the exponents, but we have a bit of a problem. Our bases are not the same. Okay, the last time I checked, 4 and 9 were not the same thing. So in this case, we're actually going to have to do the math ourselves. So 4 squared is 4 times 4. 9 squared is 9 times 9. 4 times 4 is 16. 9 times 9 is 81. And that's as far as we can go. And we did that without a calculator. It is not, you can't simplify this, I don't think. I don't think there's anything that goes into 16 and 81 evenly, so that is our final answer. So don't let these things scare you. And keep in mind, the bases have to be the same to use our exponent rules, so that they're going to try to throw a little bit of everything at you. So make sure you pay close attention to what's going on. It's not, this exercise is not based on any one particular concept. It deals with all kinds of exponent rules, so keep in mind you could see anything in this one. All right, so this one the bases are the same. So we could say, we could add the exponents and say that is 4 to the fourth, and then we could give an answer. I don't know about you, but I don't have 4 to the fourth memorized, but I do know that 4 times 4 is 16. And I know that 16 times 16 is, I want to say 196, but I'm going to check my calculator just to make sure, because I don't want you yelling at me from your screen that I'm an idiot because I did it wrong. And I do make mistakes. So no, it is 256. Okay, so 256. Now, I said in the beginning we didn't have to use a calculator. I did that there just to double check myself, but you could always do this longhand, 16 times 16, and do it that way. I just don't want you to use a calculator to do the original problem. I want you to be able to use the exponent rules. Practice those. You are more than welcome, and you are actually encouraged to use a calculator to check your answer before you submit it on IXL, but try to work these out by hand. For example, this one is very doable by hand, so let's do that. The bases are the same, and we're multiplying, so we can add the exponents. So 5 to the 8 plus negative 9 is the same as 5 to the negative 1. And then we have a negative exponent, so we're going to invert it, and we end up with 1/5, or 1 over 5 to the first power. All right, if you want to check this in a calculator, just to feel comfortable, you would type in 1/5 to get your decimal, which is 0.2. So if you type this in the calculator exactly like it is, you should get 0.12. So you can use a calculator to check yourself, but if you do this one in the calculator and you type that into IXL, you're going to miss it because they are expecting a fraction. All right, so let's look at this one real quick. First thing I notice is we have some negative exponents. The bases are not the same. So the first thing I would do is rewrite it with positive exponents. So the 3 to the third is on top. So we've used that one. 10 to the negative 1 would move to the bottom, to the denominator. It would be 10 to the first. And then we've used that one. And then 11 to the negative 1 would also move to the bottom, to the denominator, to 11 to the first power. And we've used that one. So also notice that they're all multiplied together. Keep in mind that this only works, you can only do some of this stuff in certain situations. All right, so let's simplify this a little bit. 3 to the third power is 3 times 3 times 3, which is 27. And 10 times 11 is 110. I do not think there's anything that goes into both of these equally, so I do not think that is reducible. Factors of 27 are 1 and 27. Obviously, 27 won't go into that. 3 and 9. 3 would go into 111. But nope. So that is the simplified form there. All right, so see how we can do that without a calculator? Again, if you do this in a calculator, you're going to get some kind of weird decimal. And it's not gonna count it right. So you need to work these out by hand. You can absolutely check yourself by putting this in the calculator and this in the calculator and see if they're equal to each other. All right, another one. There are several ways to work this one out. I'm sure the first thing you notice is 7 to the 7th power on top and 7 to the 7th power on the bottom. Those would technically cancel out, and you're left with just the top part. I'm going to pretend like I didn't see that at first, and I'm going to work this one all the way out just so we can practice with the exponent rules that we've learned. All right, so first thing I see is all the bases are the same. So we can do our power rules, our exponent rules without doing any math to start with. So let's do that. First thing I want to do is move this one to the bottom. Okay? And I'm just going to rewrite everything to keep it simple. Actually, we'll do it two different ways. If you move this one to the bottom first, that's going to cause you an extra step, but I'm going to do it both ways just to show you it doesn't matter. That's a 7, not a 2. 7 to the 7th is already down here. We're moving this one down, so multiply 7 to the 7th. All right, everything is multiplied on top, everything is multiplied on the bottom. So on top, we can add the exponents. 9 and 7 is 16. On the bottom, we can add the exponents. 7 and 7 is 14. Right, the bases never change throughout this. So here we can subtract. We're dividing, so we can subtract the exponents. 16 minus 14 is 2. And 7 times 7, or 7 squared, is 49. All right, so let's look at it if we do it straight across. All right, so if we do it straight across, if we don't move the 7 to the negative 7th down, we end up with 7 to the 7th on the bottom, which we're not doing anything to, so we can just rewrite. And on top, we're just going to go straight across and add all the exponents. So 9 plus 7 plus negative 7. Okay. All right, so 9 plus 7 is 16, and then plus negative 7 puts us back to 9. Or in other words, this positive 7 and the negative 7 are going to cancel out, and we're left with 7 to the 9th over 7 to the 7th. Subtract exponents. 9 minus 7 is 2. 7 squared. We get 49. Either way, as long as we do our steps right, we're going to get the same answer whether we move the negative first or if we just do the top and then do the bottom and then carry on from there.